In today's lesson, we're going to look at Chapter 5, Section 1, Graphing Systems of Equations. So we're going to take what we learned in the past of how to graph lines, and now we're going to talk about a system of equations. So when we talk about a system of equations, it's when there's two equations together. So a simple example for a system of equations would be x plus y is equal to 5 and 3x minus 2y is equal to 7. That's just a very simple example of a system of equations. Now we could have more, absolutely, but all it needs is two different equations. Okay, and then the solution would be an ordered pair that satisfies both, meaning making both of them true. So in an ordered pair, we'd write obviously x comma y, whatever it would be. Okay, so that's what we're going to be looking for. Now, in some situations, there are some different situations in which these systems work. So if the graph intersects or coincide, the system is consistent. That is at least one ordered pair that satisfies both equations. If a consistent system has exactly one solution, it is independent. If it has infinite solutions, it is dependent. If the graphs are parallel, meaning do not touch, the system of equations is said to be inconsistent, and there's no ordered pairs, meaning there's no solution. So on the next slide, there will be visual representation. So here we go. So this is what that last page was talking about. So the first line, right, where we're looking at, there are two lines that intersect. That means there's exactly one solution. And so since it intersects and there's only one point of intersection, that means it's independent, consistent and independent. The next one, that seems to be there's only one line, but there's actually two on top of each other is what they're illustrating. And so that tells us there are infinitely many, meaning at every point they're touching. So it's consistent and dependent. And then the very last one, the next one, you can see two lines that are parallel and do not intersect, which would tell us there are no solutions. So if there's no solutions, it is inconsistent. So that's what we're going to be talking about today. So use the graph at the right and determine, oops, sorry, I'm just trying to get rid of that line. There we go. Whether each system has no solution, one solution, or infinite many solutions. So let's just look here. The first one I'm going to highlight in red. So all we got to find is the line that's illustrated by y equals negative x plus 5. So right here I see negative x plus 5 right there. Okay, and the next one I'll highlight in green, y equals x minus 3. So I'm looking for x minus 3 and I find it is right here. So it looks like they intersect right there at that one point. So this would tell us there is one solution. Okay, so that's what we're doing in these examples. So now we're looking for this y equals negative x plus 5. So we already found that one once. So let's highlight that again. Okay, I'll one off a little bit. And then we're looking for the one that says 2x plus 2y equals negative 8. So here's 2x plus 2y equals negative 8. And so it looks like those two are parallel. They're not going to be touching at any time. So that would tell us that we have no solution. And if it has no solution again, that means it would be inconsistent. All right, let's do a couple more. So I'm going to do the same thing with colors. Oh, not black. So that's our answer color. I did the same thing again. I'm going to change my color. There we go. So 2x plus 2y equals negative 8. So once again, we already found that one right there. And then I'm looking for y equals negative x minus 4. And we see that there's a bubble right here that's pointing to the exact same line. So they coincide and they're literally on top of each other. So that means there are infinite solutions. Okay, let's do the next one. Y equals 2x plus 14. So I see that one right here, 2x plus 14. And then I move on 2y equals negative x plus 5 right there. And we see that they intersect right at one point, and so we can see there is one solution. So that's what we're looking for. Now, what we're going to be doing next is actually graphing our lines and then trying to determine what the actual answer is. If there's one solution, infinite, or no, none. So, graph each system of equations, then determine no solution, one solution, or infinite. If there is one, we will name it. And that's pretty easy to do. We just have to pinpoint the coordinates. So, y equals negative x plus 8. So plus 8 tells me to go up 8 on the y-axis. 1, 2, 3, 4, 5, 6, 7, 8. And then my slope of negative 1, down 1 over 1. And so I'm going to draw my line as best as possible. Okay, there's my line. And so the next one, y equals 4x minus 7. So I'm going to have to scroll down just a little bit. 1, 2, 3, 4, 5, 6, 7. Hopefully I graphed that right. And then now it's a slope of 4, so up 4, 1, 2, 3, 4 over 1. And so I draw my line. So it looks like it's intersecting at about right there. So if we were to graph that, we could see it is 3, 5. And we can test it out. We can plug them in. So we get 5, 3. So 5 equals negative 3 plus 8. Negative 3 plus 8 is 5. So that one checks out. And then I'm going to plug it in the other one. 5, 3. So 4 times 3 is 12. Minus 7 is 5. So once again, it checks out. So my final answer. So I have one solution. And the answer is 3, 5. Yep. So there we go. So now, x plus 2, y equals 5, and 2x plus 4y is equal to 2. So I'm going to use the cover-up method that we've used in the past. So if I blank out, I'm going to get my blank out square here. Okay, so let's see. If we make this, let's see here. We're going to make this a blank out. The fill color is white. There we go. Okay, so now I'm going to, like I said, this is my blank out square. So if I cover the 2y, I get x equals 5. So I'm going to graph on x equals 5, so I'm going to go to 5 for my first point, and then I'm going to blank out the x and get 2y equals 5, so solve for y, and we get 2.5. So right about there, and I'm going to draw my line as best as possible. Okay, and then I'm going to use my blank out square again. So I cover up 4y, so 2x equals 2. Solve for x, divide by 2, we get x equals 1. So I'm going to plug in for x right there, x equals 1. And then I'm going to blank out my 2x, so I get positive 4y equals 2, divide by 4. I get y equals 1/2. Ooh, that's not a very good number, but we can plug it in right there. Oh, wrong color. Right there. So there is my 2 points. Now I'm going to draw my line here. So in this case, once again, it looks like we have, now in this case, looks like we have parallel lines that they're not going to intersect. Move my blank out square here. And so it looks like they're parallel. So if they're parallel, there is no solution. If they're not going to ever touch, that means that they are parallel and there's going to be no solution.